Hello students, in this session we are going to start the chapter Chemical Reactions and Equations. Here we are going to study the chapter in detail and also you are getting notes along with the video here. So let us start the chapter. What are the topics that we are going to discuss here? We are going to understand some of the basic concepts before going to start this chapter, that is introductory part, where we are going to understand about the physical and chemical change that you have studied in your previous class. Then we will understand the meaning of chemical reaction and how do we represent this chemical reaction in the form of a chemical equation using symbols and formulae. Then the most important part of this chapter, that is balanced chemical equation. We will understand here how do we write the balanced chemical equations. There are various steps to make the balancing of chemical equation. We are going to understand here. Then we will study the one more important topic of this chapter, that is about the types of chemical reaction. In your examination, you are asked to identify the type of reaction. So at the end of this chapter, you will be able to define different types of chemical reaction and also able to understand the type of reaction. If the reaction is given, you will be able to write the type of the reaction. The different types of chemical reaction which you will understand here are combination reaction, decomposition reaction, displacement reaction, double displacement reaction. Along with all these reactions, you are also going to understand about the exothermic, endothermic reactions, oxidation redox, that is oxidation and reduction reaction also. Then we will come across the last part of this chapter, that is about corrosion and rancidity and how do we prevent this corrosion and rancidity in our daily life. So let us start the chapter now. My dear students, you have already understood about the physical and chemical change that you have learnt in your previous class, in your ninth standard. What do we mean by physical change here? Whenever the matter undergoes the change in shape, the change in size, or change in temperature or form of matter, we call that change as physical change. Form of matter means the matter may change from solid to liquid, liquid to gas, gas to solid, gas to liquid, in this way. We call such a change as physical change. What are the example you may give? Here there are various examples. Frankly speaking, there are innumerable number of examples which you can give for physical change. Melting of ice is a physical change. You can give various other examples also. Whenever the ice get melted, what happens? It changes from solid to liquid state. But the most important thing you have to remember in physical change is there is no change in the identity of a substance. This is very important to note. Because whenever the matter undergoes physical change, there is actually no change in the chemical composition. Only it will undergo the physical change. For example, if you tear a paper, the pieces of paper are formed. Again, the pieces of paper are also the parts of paper only. There is no change in the composition. You can give that example also, tearing a paper into pieces. Cutting of wood. In this way, you can give various examples. Then when it comes to chemical change, the most important thing you have to remember here is the chemical composition of the matter is changed, which results in the formation of a new substance here. Whenever the matter undergoes chemical change, what happens here? There is a formation of new substance. Here also you can give many examples. See here, I will give some simple examples. Formation of curd from milk is an example for chemical change. Milk is different and curd is different. When you take some warm milk and put few drops of curd into it, when you leave this milk for few hours like 6 to 7 hours, then this milk is converted into curd. You can easily observe that milk has different properties and curd has different properties. The taste of milk and curd are also completely different. Here the new substance is being formed. So we can call this as a chemical change. Then photosynthesis. It is also a chemical change. The plants use carbon dioxide, water in the presence of sunlight. Using chlorophyll, they will form glucose. There is a formation of again different substance there. That is also an example for chemical change. Then fermentation of grapes, digestion of our food that we eat are also examples for chemical change. Guys, so overall what you have to understand here is physical change is accompanied by change in shape, size, temperature, form of matter. But here there is no change in the identity of a substance. That is, the new substance is not formed here. Whereas in chemical change, the composition of the matter is changed, which is resulting in the formation of a new substance. This chemical change forms the basis of a chemical reaction. Whenever the chemical change takes place, we say that chemical reaction has taken place. What is the basis of this chemical change? There is a chemical reaction that is being taken place. So now we will understand about the chemical reaction. So my dear students, now we are going to understand about the chemical reaction. How do we define this chemical reaction? It is a process in which the substance or substances undergo the chemical change which results in the formation of a new substance or substances. It depends on the type of reaction. Whether a single substance is formed or two or more substances are formed, it depends on the type of chemical reaction and also the starting materials used, that is reactants. It is called as chemical reaction. There are many examples for chemical reaction. For example, burning of wood. It is an example for chemical reaction. Why do we call it as a chemical reaction? Because when the wood is set on fire, it undergoes combustion reaction to form carbon dioxide, water vapor along with ash. Yes, because wood undergoes combustion when it is burnt. What does it forms? To form carbon dioxide, water vapor along with ash. You can see here there are new substances forming here. So we call it as chemical reaction. Then photosynthesis is also chemical reaction. Boiling of egg is also chemical reaction. Because when an egg is boiled, the heat causes the denaturation of the protein present in the egg, resulting in the formation of solid mass. The chemical composition of raw egg is different from that of boiled egg. So we consider it as a chemical reaction. Now, we said that chemical reaction will result in the formation of new substance. Then what are those new substances called as? We will understand it here. We will understand about the terms reactants and products. What are those? Let's see. The substance which is taking part in a chemical reaction is called as reactant. The new substance which is formed as a result of chemical reaction is called as product. You can see here wood can be called as reactant because it is undergoing the chemical reaction. And when it undergoes combustion reaction, it will result in the formation of carbon dioxide, water, water vapor, ash. These can be called as products. The new substance or substances which are formed as a result of chemical reaction are called as products. Suppose I can represent it as, if A is a material which is undergoing reaction resulting in the formation of B and C, we call A as reactant. We can see here because it is undergoing the chemical reaction. After the chemical reaction, the products formed are B and C. These are called as products because these are the new substances formed as a result of chemical reaction. So this is about reactants and products. We will understand while studying the chemical equation. How do we represent these reactants and products in a chemical equation? Now, the question arises here, how do we understand whether a chemical reaction has taken place or not? There are few characteristics of a chemical reaction which will allow us to understand whether a chemical reaction has taken place. By observing these changes, we will understand the chemical reaction has taken place. So, what are those? Change in the state. There may be change in the state of the reactant from solid to liquid, liquid to gas, or gas to solid in this way. For example, burning of petrol. We know that petrol is liquid in state. When petrol is burnt, the gases are released like sulfur dioxides, oxides of nitrogen, carbon dioxide in this way. The liquid petroleum is converted into gaseous products. We can observe the change in the state there. So, burning of petrol can be the example for this. Then, change in color. The most familiar thing that you observe in your daily life is when iron is exposed to moist air, there is a formation of rust on the outer layer. Rusting of iron is an example because we know that iron is a shiny black metal. When it undergoes rusting, what happens? A brown colored flaky substance is formed, which is oxide of iron because the iron has undergone chemical reaction. The shiny black color material is converted into brown color dull flaky substance. There we observe the change in color. Next, also we can observe the change in temperature. Either there may be increase in temperature or decrease in temperature. Whenever there is increase in temperature, we call such reaction as exothermic reaction. In exothermic reaction, there is increase in temperature. That is, heat is released during the reaction. Or there may be also decrease in temperature. We call such reactions as endothermic reactions. Whenever the chemical reaction takes place, there may be increase or decrease in temperature in some reactions. Not in all the reaction we will observe the change in temperature, whereas in some reaction we will observe the increase or decrease in temperature. By using the thermometer in the reaction mixture, we can check the temperature decrease or increase during a reaction. For example, when you dissolve quicklime, that is tuna, which you call in Hindi, in water, what happens? There is a release of heat. The temperature of the container will increase. You can easily observe. That is change in temperature due to chemical reaction taking place. Dissolving quicklime in water. That is example for change in temperature. Here the reaction is exothermic because heat is released when quicklime is put into the water. That is, it is dissolved into water. And also in some chemical reaction you will observe that there is evolution of gases like sulfur dioxide, carbon monoxide, carbon dioxide, nitrogen dioxide, etc. There may be evolution of these gases in some reaction. The example for evolution of gas is when zinc is added. The metal zinc is added to hydrochloric acid solution. There is evolution of hydrogen gas there because the chemical reaction is being taken place when zinc is added to hydrochloric acid solution. Hydrogen gas is released along with the formation of zinc chloride. Hydrogen gas is released. We will see here the evolution of hydrogen gas. By observing that evolution of gas, we will understand that chemical reaction has taken place there, is released. Then, formation of precipitate. Precipitate means it is an insoluble substance which is formed during a reaction. For example, when potassium iodide is added, when the solution of potassium iodide is added to lead nitrate solution, then there is formation of yellow colored insoluble substance, that is lead iodide. It is an example for formation of precipitate. So this is all about the characteristics of chemical reaction. Now we have understood what do we mean by chemical reaction, and also we have understood about the terms reactants and products. Then we also have come to know what are the characteristics of chemical reaction. It is important to know these characteristics. You may be asked in your examination. Then, my dear students, understand here that there are various number of chemical reactions which are going to take place in our daily life. We cannot always make the lengthier description of this chemical reaction. The best method to represent this chemical reaction is in the form of a chemical equation. Now we are going to understand here what do we mean by chemical equation. This is a very easier form of representing the chemical reaction. Now earlierly I have said that in the example for evolution of gas, when zinc is added to HCl solution, hydrogen gas is released along with the formation of zinc chloride. But if I represent this reaction in the form of an equation, it will be very easier for us to understand. We will see the examples here. See here, what do we mean by chemical equation? It is the symbolic representation of a chemical reaction in the form of symbols and chemical formulae. It is called as chemical equation. Yes, how do we represent it in the form of a equation? By using symbols and chemical formulae. My dear students, here the most important thing you have to remember is framing the chemical formulae which you have learnt in your ninth standard. It is very important for writing the chemical equations. If you are not aware of writing the chemical formulae or framing the chemical formulae, it will be very difficult for you to understand how to write the chemical equation. Example, magnesium reacts with oxygen. That is, when magnesium is burnt in the presence of oxygen, we get magnesium oxide. This is called as word equation. This is called as word equation. We have represented the chemical reaction by using the name of the elements or compounds here. Here, these are called as reactants because they are taking part in the reaction. And this is called as product because this is the new substance formed during a reaction. The reaction is Magnesium is burnt in the presence of oxygen to form magnesium oxide. This is the chemical reaction. We have represented with the help of equation here. To make it still simpler, we will use the symbol of the elements and compounds. The symbol for magnesium metal is Mg. The symbol for oxygen molecule is O2. We will get magnesium oxide. This is the formula of magnesium oxide. So, this is called as chemical equation. We represent the reaction in the form of symbols and chemical formulae. This is the element symbol, that is Mg, magnesium, O2 is oxygen molecule. The plus sign will separate various reactants or various products. Here we have got only one product. If it is more than one product, we will separate those products again by plus sign. This arrow mark will indicate that the direction of chemical reaction is forward. The magnesium burns in the presence of oxygen to form magnesium oxide. This is the forward reaction. And here you should be able to write the chemical formula of different compounds which you have learned in class 9. I will give some examples for writing chemical equation. Let's see here. Let's take this as example. We have to write the constituents elements of the compound. Then we have to write the valencies of each element. The valency of magnesium is 2, oxygen is also 2. Then we have to crisscross the valencies. Dividing these numbers by the common factor, we will get 1, 1 here. So we can write the chemical formula of magnesium oxide as MgO. I will show you one more example here. Let's write it for aluminium chloride. The name itself indicates the constituent elements are aluminium and chlorine. The valency of aluminium is 3 and that of chlorine is 1. Crisscrossing these valencies, we will get the chemical formula of the compound. In this way, you should be able to write the chemical formula of different compounds, because in this chapter, you will come across various reactions, various chemical formulae throughout this chapter. And not only in this chapter, in the upcoming chapters like acids and bases, metals and non-metals also, you will come across different compounds having different chemical formulae. So it is very important to note down this point. Yes. Now we were discussing about the chemical equation. This representation of the reaction in the form of a symbols and formula is called as chemical equation. These are called as reactants, that is magnesium and oxygen are reactants here, and magnesium oxide is product here. You can see here, by seeing this equation, can you observe one thing here? Are the number of atoms of each element are same on both sides of this equation? You will come to know why I am asking you this question. See here, there are 2 oxygen atoms on the left hand side. We will represent the reactants on LHS and products on RHS. These are reactants. These are products. It is product. Here the number of oxygen atoms are different on both sides. Is it possible? Can we destroy any matter or can we create any matter? It is straightforward answer that we cannot create any matter. Matter can neither be created nor be destroyed. You know this law. According to law of conservation of mass, mass can neither be created nor be destroyed. What is the meaning of this? You should not rote memorize this statement. You should understand actually. What we have taken here, 2 atoms of oxygen are present. Here we have got only 1 atom of oxygen. Where did the other atom go? Actually, it will not go anywhere. The mass is conserved in any chemical reaction, so that the mass that you have taken earlier should be equal to the mass which you have got in the product side. The total mass of the reactants must be equal to total mass of the products. Remember that total mass of reactants must be equal to total mass of products. Why it is so? Because we know that according to law of conservation of matter, it can neither be created nor be destroyed. We cannot create any mass. We cannot create any matter. They undergo transformation actually. Because of that, we will say that mass can neither be created nor be destroyed. Then what can we do here? We should get the same number of atoms of each element on RHS and LHS same. That is what we call that equation as balanced chemical equation. Now we will understand what is balanced chemical equation. When the number of atoms of each element on both sides of the reactant side and product side of the chemical equation are equal in number, then the chemical equation is said to be balanced chemical equation. And again remember, why should we need to balance the chemical equation? According to the law of conservation of mass. Now let's see here. To get the same number of oxygen atom on both sides, I will write the coefficient 2 here. Now the oxygen atoms are same, but to make the magnesium atom equal in number, I will write again 2 here. Now you can observe the number of atoms of both elements are equal. And don't bother, I will explain you how to balance the chemical equation easily. Yes, right now remember that you should get the same number of atoms of each element on both sides of LHS and LHS. Yes, see here, this is a very important question. Many a time it is asked, why do we need to balance a chemical equation? Balancing a chemical equation is important in order to follow the law of conservation of mass. According to the law, mass can neither be created nor be destroyed in a chemical reaction. The total quantity of matter of elements present on reactant side should be equal to total quantity of matter of the element present on the product side, following the law of conservation of mass. This is why we will balance the chemical equation. So we will get the same quantity of reactants and products, because we cannot create any new matter or we cannot destroy the existing matter. Only they get transformed from reactant to product. Yes. And in the next session, we will learn how to balance the chemical equation. Now, let me give some examples for balanced chemical equation. See here, this is zinc metal. When it is added to dilute hydrochloric acid, we get zinc chloride and hydrogen gas. Now, I will directly write the balanced chemical equation. But do not worry, we will understand it how to balance the chemical equation in our upcoming session. See here, there is only one zinc atom on both reactant and product side, two chlorine atoms on both reactant and product side. Remember that we are going to write the coefficients in front of these compounds or elements. These are called as stoichiometric coefficients. When you write the coefficients in front of any chemical formulae, it is applied to both the constituent elements. You should multiply both the elements by this number, which means here 2HCl indicates that this 2 is applicable both to hydrogen and chlorine, such that we are having 2 hydrogen atoms here and also 2 chlorine atoms here. But this subscript indicates this number is belonging to only this element, that is chlorine. You have to remember this difference. While making the equation balanced, you should never change the formula of the compound. It is very important to note that. You can only write the coefficient in front of these formulae, but you are not allowed to change the chemical formula of any compound. Now we are having one zinc atom here, one atom here also, two chlorine atoms here, two chlorine atoms here, two hydrogens here, two hydrogens here. So this equation is balanced chemical equation. We are having the same amount of reactants and products. Let me give you another one example. I have directly written the balanced chemical equation. You can see here there are two nitrogen atoms here, two nitrogen atoms here, 3 twos are 6 hydrogen atoms here, and 2 threes are 6 hydrogen atoms here. Whenever you will be having the subscript, you have to multiply them. 3 twos are 6 hydrogen atoms, 2 threes are 6 hydrogen atom. This 3 is belonging to only hydrogen, not nitrogen. This number, which is called as stoichiometric coefficient, should be multiplied to both the constituent elements here. This is called as balanced chemical equation, as we are having the same number of atoms on both the side of the equation. This N2 represent it is a molecule. I can represent it. I can represent it in the form of molecule like this. This is N2 molecule. For your understanding purpose, I am drawing here the molecules. Three hydrogen molecules. What this 3H2 indicates? We are having three hydrogen molecules. Suppose this is one hydrogen molecule, this is another hydrogen molecule, this is another hydrogen molecules. Here we are having three hydrogen molecule, which will result in the formation of two ammonia molecules. This NH3 is ammonia. This is one ammonia molecule. This is another ammonia molecule. Just for your understanding purpose, I have written how the things work. This is one N2 molecule which combines with three hydrogen molecules to form two ammonia molecules. Now you have come to know how do we represent the chemical reaction in the form of a equation. Yes, in the upcoming session, we are going to discuss the very important part of this chapter, that is about balancing a chemical equation, because we have many number of chemical reactions that we come across throughout this chapter and also upcoming chapters. We will understand the various steps to balance the chemical equation.